Hey guys, this is Mrs. Lyons. I am going to make a homework walkthrough for you so that if you get stuck on the homework, you can come and look at this and hopefully it will help you predict products of a double replacement reaction. Okay, so the first thing that you're going to do with double replacement reactions is write the word equation. My puppy is moaning. He wants my attention. We'll see if he can keep his cool. All right. So we're going to write the word equations, okay? And to do that, you're just going to switch. So in this case, I'm going to switch barium with sodium, okay? So what that comes out to be is I'm going to have sodium chloride plus barium phosphate. Okay, so you're just switching the metals, okay? Now, when you go to write the chemical formulas of these, okay, it's going to be necessary to look at the charges, okay? And what I find is the easiest way to do this is to look at the charge and just write it above the chemical element. So for example, barium is +2. So I have barium in two places. Barium is +2. All right. Chlorine is -1. So over here, chlorine is -1. Sodium is +1. And phosphate is -3. Okay, so now that I've done that, now that I've looked at the charges, now I can start to write the chemical formula. So for example, this would be BaCl2. Remember, we crisscross our charges. And this would be Na3. Oh, wait, what? What is phosphate? Don't forget. Don't think phosphide. Don't forget, you got to look back here on the back of your periodic tables and find phosphate is PO4 with a -3 charge. Excuse me, I'm sleepy, I'm yawning. Okay, so that's where I get that -3. It's not phosphorus, it's phosphate. So it's going to be Na3PO4. And if you want to put it in parentheses and put a 1 after it, I'm not going to count it wrong. Those are going to produce sodium chloride, which is NaCl, plus barium phosphate, which is going to be Ba3PO4 2. Now, we are not going to talk about what state of matter these are in. We'll get to that later this week. For right now, I just want to predict the products. Okay, so number 2, lithium sulfate plus magnesium nitrate. So we're going to switch lithium and magnesium. Okay, so I'm going to have magnesium nitrate plus lithium. What did I just do? Oh, shoot. Did you see that? I screwed up. Magnesium, I'm sorry, sulfate and lithium nitrate. Okay, so you can see how easy it is to mix these up. So just kind of be careful when you're doing this so that you don't get them confused. Okay, so now I'm going to look at my charges. So lithium forms +1 ions. Sulfate is SO4. If I look at the back of my periodic table, sulfate is SO4 with a -2 charge. Magnesium has a +2 charge. Nitrate is NO3 with a -1 charge. Magnesium is +2. Sulfate is -2. Lithium is +1. Nitrate is -1. All right, so I'm going to have Li2SO4 plus MgNO3 2 produces, now magnesium and sulfate are both 2, so those cancel out. So MgSO4 plus lithium nitrate, LiNO3. Now, I did not balance the first one, and then I realized we should probably balance these because these are really good practice for balancing. Okay, so let's go back and balance that first one. All right, and I'm going to rewrite it. So I've got BaCl2 plus Na3PO4 produces NaCl plus Ba3PO4 2. Okay, so now what I'm going to do is I'm going to make a list. So I've got barium, I've got chlorine, I've got sodium, and I've got PO4 on both sides. So I'm going to use that, and I can just count how many PO4s I have on each side. All right, so let's see. Here I have 1 barium. Over here I have 3. Here I have 2 chlorine. Here I have 1. Here I have 3 sodium. Here I have 1. Here, now don't forget this PO4, we just have 1 of them. And over here we have 2. Okay, so make sure you don't write 4 of those because that will send you off down a rabbit hole that you'll never find your way out of. All right, so let's look. I have 3 barium over here. So if I put a 3 here, now I have 3 barium, but I have 3 times 2, so I have 6. Whoops, 3 times 2, so I have 6 chlorines. Okay, let's see. So let's go ahead over here. I only have 1 chlorine, so I'm going to put a 6 here. That will give me 6 chlorines, but it'll also give me 6 sodiums. So here, I'm going to put, I have 3, so if I put a 2 here, now I have 6 sodium and 2 phosphate. So there we go. That equation is balanced. Okay, so let's look at the second one. So in this one, I have lithium, I have sulfate, I have magnesium, and I have nitrate. All right, so I have 2 lithium, 1 sulfate, 1 magnesium, 2 nitrate. Over here, I have 1 magnesium, 1 sulfate, 1 lithium, 1 nitrate. Ah, sweet. This one's nice because all I have to do is put a 2 in front of lithium nitrate, and my equation is balanced. Okay? All right. Number 3. So number 3 says we have potassium oxide and calcium chlorate. So I am going to switch potassium and calcium. So I'm going to write potassium chlorate plus calcium oxide. Now, let me just make a note here. Okay, it does not matter which one you put first in terms of the compounds. The only thing that matters is that the metal comes first. So potassium has to be first. Calcium has to be first. Okay, all right. Now, if I look at my periodic table, potassium makes +1 ions, oxide -2, calcium +2, chlorate is ClO3, and that's a -1 charge. Okay, so we said potassium's +1, chlorate's -1, calcium's +2, oxide's -2. So I just do those charges up there so that I don't have to actually write my symbols twice. I can just kind of think about, okay, I crisscross these. So I have K2O plus CaClO3 2, reacts to give me KClO3 plus CaO. All right, now let's balance. I've got potassium, I've got oxygen, I've got calcium, I've got chlorate. So I've got 2 potassium, 1 potassium, 1 oxygen, 1 oxygen, 1 calcium, 2 chlorate, 1 chlorate. Oh, good. This is another one that's not terrible. I can just put a 2 here, and my equation is balanced. All right. We are going to skip number 4. So number 5. Again, so I'm just going to do silver nitride plus. Now, if we have transition metals, the charges are going to stay the same. Okay, so this over here is still going to be tin 4 acetate. Okay, so silver, remember silver is always +1. Acetate is that weird one, CH3COO with a -1 charge. Tin, this tells us it's got a +4 charge. Nitride is -3. Silver's +1, nitride's -3, tin is +4, and acetate is -1. So I end up with AgCH3COO plus SN3N4 produces Ag3N plus SnCH3COO4. Whew, let's balance. So I have silver, I have acetate, I have tin, and I have nitrogen. So 1 silver, 3 silver, 1 acetate, 4 acetates, 3 tin, 1 tin, 4 nitrogen, 1 nitrogen. Ooh, this one looks like it could be tricky. Let's see how this works. All right, so I've got 3 silver over here. So I'm going to put a 3 here. All right, that gives me 3 silver. And it also gives me 3 acetate. Ooh, this one's going to be messy. Do you see why this one's going to be messy? We have 3 and 4. The least common multiple of 3 and 4 is 12. So I'm betting that we are going to have to get to 12. And I'm going to do tin next. So if I look, I have 3 tin here and only 1 here, which means I need a 3 here. Look what that does. It gives me 3 tin. But notice what it does to my acetate. It gives me 12. So I am indeed going to have 12 acetate, which means this 3 over here just won't do. This is going to have to be a 12. All right. And so now I have 12 silver and 12 acetate. All right, let's see. So here I only have 3. So if I put a coefficient of a 4 there, 4 times 3 is 12, which leaves me with 4 nitrogen, and I am balanced. Now, anytime that you get into numbers that are big like that, one thing you want to do when you get it balanced is go back and look at your coefficients. And in this case, it's okay. I've got 12, 1, 4, 3. So those can't be simplified. If your coefficients can ever be simplified, you should simplify them to the least whole number ratio. Okay, in this case, it worked. Not a big deal, but sometimes when you go through that back and forth, you might take it a step too far. And technically, the definition of a balanced chemical equation is using the smallest whole number ratio. All right. All right, so let's see. Let's go to number 6. so we are going to switch lead 2 with strontium. All right, so I'm going to have lead 2 carbonate plus strontium iodide. All right, so let's see. If I look at this, lead has a +2 charge. Iodine is -1. Strontium is +2. Carbonate is CO3 with a -2. That's on the back of your periodic table. Lead is +2. Carbonate is CO3 -2. Strontium's +2. Iodide is -1. So when I go to write this all out, I have PbI2 plus SrCO3 produces PbCO3 plus SrI2. Now this one is super sweet. Do you notice this is already balanced? One lead, one iodine, one strontium, one carbonate, one carbonate. Those are the kind I like. All right, we're going to skip number 7. So number 8, we have zinc oxide. So I'm going to switch this. I'm going to say I've got zinc nitrite, plus cobalt 3 oxide. All right. Remember, zinc always has a +2 charge. Oxide is a -2. Cobalt is +3. Nitrite is NO2 with a -1 charge. Zinc is +2. Again, nitrite, NO2, -1. Cobalt's +3. Oxide is -2. And by writing these charges, I feel like it just makes it easier than if you have to do zinc +2, oxygen -2, and then rewrite it, because I don't want to see, whoops, you can't see what I'm doing. I don't want to see your charges as part of your chemical equation. All right, so I need to slide this up so you can see what I'm doing. All right, so I have ZNO, that is, those cancel each other out, plus CONO2 3 produces ZnNO2 2 plus CO2O3. Woo. All right, now I shouldn't put that there. So let's balance. We've got zinc, oxygen, cobalt, and nitrite. All right, I have 1 zinc and 1 oxygen. I have 1 cobalt and 3 nitrites. Over here, I have 1 zinc and 2 nitrites. So 1 zinc, 2 nitrites, 2 cobalt, and 3 oxygen. So 3 and 2. All right, so let's see. My oxygen is out of balance. So if I put a 3 here, that gives me 3 zinc and also 3 oxygen. So let's see, 3 zinc here. So if I put a coefficient of a 3 here, I have 3 zinc, and 3 times 2 is 6 nitrites. So that's balanced cobalt. There are 2 over here and only 1. So I'm going to put a 2 here. That gives me 2 cobalt and 6 nitrite. So that is balanced. All right. We are going to skip number 9. So number 10, let's slide this up a little bit. All right. So we have copper dichromate plus iron arsenate. Ooh, that's a lot of stuff. So I'm going to end up with copper 1, arsenate plus iron 3 dichromate. Ooh, I didn't leave myself enough room to write. All right, dichromate. Now, charges. These are some that aren't quite as familiar, and I don't want you to get confused by that di in dichromate. There is actually a polyatomic ion called dichromate, Cr2O7. Okay, so I'm going to write that up here, Cr2O7, and it had a -2 charge. So copper's +1, dichromate is -2, iron is +3. Arsenate's another one that you don't see very often. Arsenate is ASO4 with a -3 charge. So ASO4 with a -3 charge. So then we get +1 copper, -3 arsenate, +3 iron, and -2 dichromate. All right, so we have copper, copper 2, Cu2, Cr2O7 plus FeASO4. Those are both 3, so the 3's cancel each other out, plus Cu3ASO4 plus iron 3, so Fe2 dichromate Cr2O7 3. All right, so let's balance this one. So we have copper, we have dichromate, we have iron, and we have arsenate. All right, so 2, 3. We have 1 dichromate here. We have 3 dichromate there. We have an iron. Over here we have 2 iron. Here we have 1 arsenate. Here we have 1 arsenate. Okay, so let's see. What should we do? Well, we might as well just attack that copper right off the bat. So if we see 2 and 3, that means we have the least common multiple, right, of 6. So if I want 6 copper over here, I have to do 3 times that 2 gives me 6 copper, and it gives me 3 dichromate. Now, over here, we still need to get 6 copper, so we're going to put a 2 here. So 2 times 3 gives me 6 copper and 2 arsenate. All right, so my copper and my dichromate are balanced. My iron and my arsenate are not. But that one's not terrible. If I put a 2 here and a 2 here, 2 there gives me 2 of these and 2 of these, and I am now balanced. All right. All right. We're almost there. We're going to skip number 11. We're really almost there. All right. Combustion reactions. Combustion reactions are a different beast because there are some tricks to these. And we're going to just get right in here with this trick to start with. First of all, notice we didn't even bother with words because we haven't learned really the formal name of this is ethane. We would call it dicarbon hexahydride. I'm not going to worry about words for those. Okay, so I'll just give you a formula. What you need to know is the product of combustion reactions are always CO2, carbon dioxide, and water. Okay, now carbon, hydrogen, oxygen. Do them in this order. So carbon, there are 2 carbon here, 1 carbon here, 6 hydrogen, 2 hydrogen, 2 oxygen, and 3 oxygen. Don't forget we've got 2 here and 1 here, so 3 oxygen. All right, now I'm going to balance the carbon first. If I put a coefficient of a 2 here, that gives me 2 carbon. I'm not going to add up the oxygen until I get the water done because it'll change. Okay, 6 hydrogen. So if I put a 3 here, I have 6 hydrogen. Okay, now let's add up water. So 2 times 2 is 4. And then here I have 3. So I have a total of 7 oxygen. What times 2? So what am I going to put in here? What times 2 is 7? Well, 3.5, right? 3.5 times 2 is 7. Here's the problem. You cannot have 3.5 oxygen. So what you have to do when you get this is you just double everything, okay? Which means we put a 2 here, a 7 here, a 4, and a 6. So let's just count these up so we are sure. So 2 times 2 is 4 carbon. Over here I have 4 carbon. 2 times 6 is 12 hydrogen. 6 times 2 is 12 hydrogen. And then we have 14 oxygen. So here I have 4 times 2 is 8, plus 6, 14. Okay, so that's a little trick for balancing those hydrocarbon compounds that will come in handy. All right, we are now going to balance, and I'm going to change this one because we're not really doing the nitrogen-containing compounds. So we're going to change this to O. Okay, so C2H5O plus O2. So it's just a combustion reaction of a hydrocarbon. So our products are CO2 plus H2O. All right, now let's tally carbon, hydrogen, oxygen. I have 2 carbon, 5 hydrogen, 3 oxygen, 1 carbon, 2 hydrogen, 3 oxygen. Okay, this one's interesting, isn't it? Because we've got 5 hydrogen and 2 hydrogen. So if you think about that, the least common multiple of 5 and 2 is 10. So I'm going to put a 5 here. No, sorry. I'm going to put a 2 here. 2 times 5 gives me 10 hydrogen. And then I'm going to put a 5 here. 5 times 2 is 10 hydrogen. And I just did that because I noticed right off the bat, I'm like, 5 hydrogen and 2 hydrogen, that's not going to work. We didn't have to do the double thing like we do with oxygen because hydrogen's only in one of the compounds. Okay, so now we have 4 carbon. And so if we put a 4 here, that gives me 4 carbon. Then we have 8 plus 5, we have 13 oxygen. Oh no, did I do, is this one going to be one of those? This one's going to be impossible. All right, so 13 and 3, guess what? I'm not even sure if this one balances. Well, I'm just going to carry this through, guys, and we will see. All right, this will show you what happens sometimes when you get to balancing these things. All right, so I'm going to double this, just like we did on the last one. So I'm going to say I've got 10 H2Os now, which gives me 20 hydrogens. And then I'm going to say I have 10. Now, let's see, I need 4. 4 of these. 4 times 5 is 20 hydrogens. All right, now I have 4 times 2 is 8 carbon. So 4 times, so I need 8 here. That gives me, I should do this 4 times 2 is 8. Right, if I put an 8 here, I have 8 carbon. All right, so let's see, I've got 4 times 2 is 8 carbon, 8 carbon. 4 times 5 is 20 hydrogen. 10 times 2 is 20 hydrogen. Okay, so let's say a prayer and hope that our oxygen can be balanced. So we have 8 times 2 is 16 plus 10 is 26 oxygen. All right, so remember here I have 4 oxygen. Okay, so if I take 26 minus 4, that's 22. And if I put an 11 there, I now have, so let's see, does that work? If I put an 11 there, 22 plus 4 is 26. And over here I have 26. Is that right? Let's double check. 8 times 2 is 16, plus 10 is 26. 4 times 1 is 4, plus 22 is 26. So I think that one is balanced. And just to check, okay, remember I said sometimes when you get into these cycles and you go and you go and you go and you think, what if I went too far? If I look, I've got 4, 11, 8, 10. That can't be simplified, so I didn't go too far. So my equation, let me just write this, is 4C2H5O plus 11O2 produces 8CO2 plus 10H2O. All right, you will not have one that hard on a quiz or a test unless it's worth extra credit. All right, let's do one more. Oh, this one's going to be a piece of cake after that one. C3H8 produces CO2 plus H2O. This one, I bet, and I'm just gonna do it in my head. I bet some of you can do this. I've got 3 carbon, so I put a 3 here. All right. I have 8 hydrogen, so I put a 4 here. Then I add up my oxygen, so 3 times 2 is 6, plus 4 is 10. I can put a 5 there, and voila, it is balanced. All right, guys, that is your homework. I hope this walkthrough helped, and I will see you in class. Take care.